Okay, for number 4, I'm going to the whiteboard, and I'll write it down, and then I want to see if I can solve it, all right? So whiteboard, and let's go writing that down. I would say the act of writing something down might allow you to move forward. Let's write this down. So it's 1 minus x squared plus x4 minus x6. And inequalities always are confusing to me. There's a lot of problems with inequalities, especially if you have negative numbers. This is 1 plus x squared, and this is a double inequality. And I want to see if I can figure it out. I'm going to solve it. Before I go on to solve it, I want to see if I wrote the right thing down. And I see 1 minus x squared plus x4 minus x6, less than or equal to 1 over 1 plus x squared, less than or equal to 1 minus x squared. Oops, I made a mistake. That's plus x4. I'm glad I'm looking. Minus x6 plus x8. I think I did okay. Now, one thing I noticed about this over here is that 1 plus x squared for a real number system is always greater than 0. So I'm not worried about this thing changing its direction. So I'm going to multiply both sides by 1 plus, I'm sorry, all sides by 1 plus x squared. Let me write this down. Again, this may be a dead end, but it can't hurt to write something down. This would be 1. And what's this over here? It's going to be 1 minus x squared plus x4 minus x6 plus x8. And again, this may not be helpful, but I'm going to try to multiply it out. And what would you get over here? You would get 1 minus x squared plus x4 minus x6. If you multiply by x squared, what do you get? You'd get x squared. Let's see. X4, minus x4, I'm sorry. X6, and then minus x8. Well, isn't that convenient? And what do you get over there? You get 1 minus x to the 8th power. And this is 1. I want to check it. And you certainly get 1 minus x squared plus x4 minus x6. Then you get x squared minus x4, x6 minus x8. The x squared disappears, the x4 disappears, the x6 disappears. Yeah, that looks pretty good. Let's do the other thing. What do you have here? 1 minus x squared plus x4 minus x6 plus x8. Let's see, what do you get there? X squared minus x4 plus x6 minus x8 plus x10. Well, isn't that convenient? What do you get there? 1 plus x10. All right? Now, by the way, things did simplify nicely. I'm still looking at, wonder what to do now. I'm going to subtract 1 from all sides. And what do you get over here? Minus x8. I'm subtracting 1, by the way. 0. And then you get x10. All right? Time to start thinking. Because I got something over here. And they say 0 is bounded between those x10 and x to the 8th. So I want to talk about, like, if x were 0, would that hold true? Yeah, that holds true. Because you get 0, less than or equal to 0, less than or equal to 0. So 0 works. Now let's say we take positive numbers. Well, like, let's say you took x greater than 0. Would it hold there? Well, yeah. And the reason for that, when you're taking a negative, positive to an 8th power, you get a positive number. And a negative of a positive is certainly less than 0. And this side over here would certainly be positive. Again, what I'm looking at over here, I'm looking at, let me go to the colors again. Oh, it's right over here. I'm looking at this over here. So if x is 0, this would be 0, that's 0, that's 0. And that certainly holds. If x is greater than 0, this would certainly be a negative number. Negative numbers are certainly less than 0, and that would certainly be a positive number. Let's do the next one, which is x less than 0. All right, I'm trying to solve the inequality now. Now, if x is less than 0, I want to point out this thing's still going to be negative. And why is that? When you take a negative number to the nth power, it's going to be a positive number, but it says it's negative of that. And zeros are greater than that. And this over here, negative number to a positive power, so its 10th power is going to be a positive number, certainly holds. So what solution is over here? X could be any real number. If you write down in radical notation, x is between minus infinity and infinity. And that is now done. Thank you.